Okay. So I'm going to do a quick introduction to how to solve these network flow problems. So here's a network, and it's different from the other networks you've got in that there's some arrows on it, so it's directed. So you want to think of this network as something like a series of pipes where water's flowing down, and the arrows show you which direction the water can move down the pipe, and the numbers, the weights of the edges, tell you how much water can go down the pipe, for example. So here, S to A, you could have 8 litres per second or something like that. So you have the numbers that tell you the capacity of the pipe, or the capacity of the edge, and then the arrows tell you the direction of the edge. Okay. So what we're going to try and do, or the idea of the problem, is to try and find the maximum flow that we can send through this network. So there's a few things you just need to know before you can do that, and that is, first of all the flow starts at one point called the source, and that's usually given the letter S. So this over here is the source, where the flow starts, and it all finishes at a place called sink, which is usually given the letter T, like that. And in between the source and sink, there's no capacity can get lost. There's no leaks in the pipe, so everything that comes from the source has to end up at the sink. Okay. We have a theorem. I'm going to write down here is that the maximum flow, which is what we're trying to find, is equal to the minimum cut. Okay, so what do I mean by a cut? So a cut is me drawing a line through this network, like that, somewhere where I can cut the edges. And if I just add up the edges that I've cut through, so I've cut through 4, 5, 6 and 10, that adds up to 25. So that cut there would be 25. Okay, so if I can find a cut with the minimum value, it should be equal to the maximum cut. It should be equal to the maximum flow through the network. Now, you have to be careful on some questions, because in this example that I've put on the board, it's quite a straightforward example because all the arrows are pointing the same way. But for example, if this arrow here was pointing that way, and I did the cut again, so I cut through here like that, I only add, when I do my cut, I only add the weights in which the arrows are pointing towards the sink. So I'm going to add 4 because the arrow is pointing to the right. And on this one here, where I cut this edge here, the arrow is pointing to the left, so I'm not going to add that weight. I'm going to add this one, and I'm going to add this one, so that would be a cut of 20. Okay, so when I do my cut, I only add the weights with the arrows that are pointing towards the sink, so you just need to be aware of that as well. Okay, so let me just change that background. Okay, so what we're going to do is, first of all, we'll try and see if we can find this minimum cut, and then we're going to do the algorithm and see if we can find the maximum flow, and hopefully the two values will match, which means that we've got the right maximum flow. And it looks to me like the minimum cut is going to be here. So if I cut there, both the arrows are pointing to the right, and so the minimum cut looks to me like it's going to be 14. Okay. So I'm going to make a note of that up here. So for this question, I think the minimum cut is 14. And now I'm going to do the algorithm, the way you go through the network and find the maximum flow, and hopefully we'll get the same answer. Okay? So I'll show you how to do the algorithm now. Is everyone okay? Oh, this is on D2, yeah? Can you remember how to do it? Oh. I hate D2, I think it's one of the hardest ones. Okay, so the first thing you want to do is make a note of your flows. So I'm going to do that down here. What shall we use? Let's use that colour. Okay. So I'm going to make of the flows. What I mean by that is I'm going to find a route through the network. And the first route I'm going to do is I'm going to start at the top. I'm going to do SADT. So I'll write that down. SADT. Okay, so I'm going to look along that route and I look at the weights and all the arrows point that way. So I've got 8, 4 and 10. And then I think about what's the most capacity I can send down this route, SADT. Well, I can't send 8 down the route. I can send it between S and A, but then I can't send it between A and D. So I'm just looking for the smallest weight. And the smallest weight down that route is 4. Okay, so I can send 4 down that route there. And what I'm going to do is I'm going to edit the graph now. I'm going to assume I've sent 4 down that path. And I'm going to edit the graph. So if I've sent 4 down this path, then there's going to be no more capacity in A to D. So I'm going to put a 0 there. But I could send 4 back the other way. Okay, so there is 4 flowing in that bit of pipe there. So I can't send any more down the pipe because it only holds 4. But I could push 4 back up the pipe. Okay, I could divert the water or whatever it is back down the pipe like that. Okay. So if I've sent 4 between S and A, then there's 4 left to carry on. But I could also send 4 back. And over here, I could send 4 back, and there's still a capacity of 6 left in that pipe there. Okay. And what we'll do now is just mention that A to D, there's nothing else I can send from A to D. So we'd say that bit of pipe there, or that edge is saturated. There's nothing else that can be sent down there. Okay, so now I'm going to pick another route, and this time I'm going to go S to A, because I can still go S to A, and then I'm going to go S to A, C to D to T. Okay, so I'm going to write that down. So we're going to go S to A to C to D to T. Okay, so I look down this route, and S to A has now got a capacity of 4. There's a capacity of 5 from A to C, there's a capacity of 4 from C to D, and there's a capacity of 6 from D to T now. So the minimum is 4, so I can send 4 down that route. And again, I'm going to edit the values in this network now. So I send 4 down this route, so that means that S to A, cross those out. I've sent another 4 down here, so now S to A is saturated, but I could send 8 back down the pipe the other way. Okay. I sent 4 down this pipe, so that means there's 1 left that I could send down there. I sent 4 down here, so that means that pipe there is saturated. And then I'm going to send another 4 down from D to T, and that means that I could still send 2 down the pipe, or I could push 8 backwards through the pipe. Okay. Okay, so now I'm going to pick another route, and this time I can't go from S to A because it's saturated, so I've got to go S to B. Let's come down a little bit. I'm going to go S to B, and then from B I can go to C, and then I can go to T. So I look down this path, and I've got S to B is 6, B to C is 6, C to T is 2, so the most I can send down that path is 2, and then I'm going to just do the algorithm on here. So if I've sent 2 down that path, I can send 4 more down, or I could send 2 back by diverting it. I could still send 4 up this one, and this one here now, C to T, is saturated. I sent 2 down it, and so I can send no more down it. Okay. But the reason I'm putting the arrows pointing backwards is I could take the 2 I've sent down it and push it back down the pipe if I wanted to. Okay. Right, now I've got, what other path can I do? I can do S to B to C to E to T. S to B to C to E to T. So I look down this route, S to B to C to E to T, and I look at the weights I've got now, or the capacities for the edges. S to B is 4, B to C is 4, and then C to E is 3. So that's going to be the smallest. So I'm going to send 3 down this path here. Okay. So I can take 3 off here. So I can still send 1 down there, or I could send 5 back down the pipe. I'm going to send 3 down here, so I can still send 1 down that bit there, or I could send 5 backwards. I sent 3 down this pipe, so I can send no more down there, but I could send 3 back up the pipe. And I've sent 3 down here, but I still could send 5. There's still a capacity for 5 in that pipe. So that was 3 in that one. And I think there's just one more path I can do for here, which is S to B to E to T. So I look down that route, S to B to E to T, and I can see S to B. I can only send 1 more down there. It's only got a capacity of 1. So the minimum in this bit here is just going to be 1. So I'm going to send 1 down this path, and it's going to mean that this is now saturated. Set 1 down here, so I've still got 9 I could send up there, and I sent 1. Sent another 1 down here, so now I can only send 4. Carry on sending 4 up there, and this is now 4 like that. Okay. So I've got my flows. I've got 4, add 4, add 2, add 3, add 1, and that gives me a flow of 14. Now we found the cuts earlier, and we said that the minimum cut was 14. I can't see any more paths through the network, because if you look at it, this edge here is saturated, this edge here is saturated, so it's actually, I can't actually get any more out of S there. There's no paths I could take from S. So this here, if I add up all the paths I've done, I get a flow, or a max flow of 14. And I check it usually by doing a minimum cut, and we did the minimum cut at the start in this question, and we found that it was 14, and it was when we did the cut here, 8 add 6. Okay, so that's how you find the maximum flow through a network. Okay, we're going to do a slightly more complicated example now. Okay, so now we're going to look at this slightly more difficult question. You should be able to see straight away it's more difficult for a couple of reasons. Firstly, there seems to be 2 sources, A and B, and there's also 3 sinks, E, F, and G. And the other thing that makes it a bit more complicated is you should see that some of these arrows are not necessarily pointing in the direction of the sink. I'm not really sure about that one there. Okay, so let's just talk about how to deal with this. Okay, firstly, you want to add on to the graph a new node, and we'll call that the source, and we call this a super source. Okay, so it's a source that doesn't really exist. There's 2 places where, for example, the water could start, but we're going to pretend that it all starts from 1 place, and we're going to add these edges onto the network, and I'm going to add my own weights onto there. So from S to B, I just look at what can go from B to D. So the weight on there is going to be 4. Okay, but from S to A, the weight there is going to be 9, because if I send 9 from S to A, it could get split up then to 6 and then to 3. So from A to C and then from A to D. Okay, I'm going to do a similar thing on the other side for the sink. So let's just put a T there, and we've got T to F is going to be, oh sorry, F to T is going to be 4, and then G to T is going to be 10, and this one is a bit more straightforward. It's going to be 5, right? Okay, So there, we got rid of the two sources and the two sinks by turning them into one super source and one super sink. Okay, and now we're just going to start the algorithm again, but I've got to be careful with these arrows. So there's quite a few pass through here. So what should we start with? Should we do S to, what should we do? Should we start from the top? S to A to C to E to T. Is that a route? Okay. So I look along this path, and I've got 9, 6, 5 and 5. So the minimum one through there is just 5. Okay. And now I'm going to go and edit that path. So let's use yellow, shall we? So I've sent 5 down that route, so that means I can not send any more down here, but I could send 5 back. Okay, if that pipe has got 5 litres of water running through it per second, I could push that 5 litres of water back. Okay, but I couldn't push any more down the pipe. Okay, we've got the same idea here. Can't push anything else down that pipe. We say those are saturated. I could put one more. That now has a capacity for 1 more, and this one here has a capacity for 4 more. Okay, so that's that path done, and you can see that C to E is saturated and E to T is saturated. So now I could look for another route, and I could do S to A, to C, to, oh, what, that hasn't even got a letter. What could that be? What have we got to do? F. Did that be out or something? Have we got an F? Alright, G, should we call it H then? There we go. So S to A to C to H to T, is that okay? S to A to C to H to F to T. How's that? So we look down there, and I think we can see A to C has just got a capacity of 1, so I can just send 1 more down there. And again, I'm going to edit these things. So now I add 1 to this side and take 1 from that side, so I can still send 3 down that pipe. This pipe now is saturated. I can still send 6 down this one, but I could push 1 back. I can still send 3 down here, but I can push 1 back. And I can still send 3 down here, but I can push 1 back. Okay. So what we're going to do next, A to C is saturated, isn't it? So I've got A to C saturated, C to, what's that up there? C to E saturated. So what should we do next? Should we do S to A to D? Should we do that? S to A to D, to H to F to T. Okay, look down there, and I can send 3 from S to A. I can send 3 from A to D. Actually, hold on a sec. I can't go from D to H, can I? Because the arrow's pointing the other way. So that's going to be no good for us, is it? So I can't do that route. So we'll have to get rid of that and edit it, and we'll have to go S to A to D to G to T. So S to A to D to G to T. Is that right? So S to A is 3, A to D is 3, D to G is 10, and then G to T is 10 again. So I can send 3 down this route here. So again, I'm going to edit these. That's now S to A is now saturated. A to D is now saturated. I can take 3 from this pipe, so I can still send 7 down it, and the same here. Still send 7 down there. Okay. So I sent 3 down that route. And now, because S to A is saturated, I'm going to have to do S to B to D to G to T. S to B to D to G to T. Okay, and S to B is 4, B to D is 4, D to G is now 7, and G to T is now 7, so I can send 4 down there. And let's just edit this. So that one's now saturated. This one's now saturated. I send 4 down here. So that means I can still send 3 down there. And I can still send 3 down there. Okay. Now, let's have a look. S to A is saturated, and so is S to B. So I think we're probably finished there. I can't see another path through there. So if I add up these flows, we should get the maximum flow. So 5 add 1 is 6, add 3 is 9, add 4 is 13. So the max flow, we reckon, is 13. And I can check this by trying to find now a minimum cut. So that's what we're going to do. We're going to have a look for a minimum cut. So we'll do it the other way around to the other question. So yeah, it looks like the minimum cut is there. 9 and 4, 13. And if the minimum cut and the maximum flow match, then you've probably got it right. Okay, so I'm going to do one more example, and this one looks a little bit more simple than the last one we did, but I'm going to do this example to try and show you one other thing you have to think about when doing these networks, and that's an idea called backflow. Gosh, just be quiet a second. Backflow is something you might come across if you pick a certain order of choosing your paths. So this time I'm going to deliberately pick a path that's going to cause something called backflow. Now usually when you go through the network, you're going to start from the top path and work your way down. But sometimes it might cause some problems, and you come across this idea of backflow, which is confusing to a lot of people, but I'll try and use a simple example to see how it works. So firstly, I'm going to not start with the route SAT, but I'm going to purposely pick the routes to start with S, A, B, T. Now it might be that on your exam, the exam question asks you to do a certain route first, deliberately making backflow appear. So you have to deal with it. So if I were to ask to do SABT first, then I would look at the routes S to A to B to T, and I would see that 2 is the minimum on that route. So I'm going to take 2 off here, and so B to T is now saturated. I'm going to take 2 off here, so I can still send 1 from A to B. And I'm going to take 2 off here, so I can still send 3 up that direction. Okay. Now, that means that there's 2 in that path there. Okay. Now, what I can do now is I can actually, it will then ask me to then go on and find the rest of, once I've done that particular path, then go on to complete the algorithm for the rest of the network. Now, I can actually, I'm allowed now to do the route S, B, A, T. Okay. Now, I wasn't allowed to do this route just now because I just had a capacity of 3 going from A to B. But now that I've sent 2 down S to A to B to T, if you look at this link, the network edge A to B here, you can see because I sent 2, I can send 2 now back up from B to A. I can push that 2 backwards through the pipe. So I've changed the capacity of it, and we call this idea backflow. So I'm now going to look from S to B to A to T, and you can see that from S to B, I've got a capacity of 5. But now, because I've done a SABT previously, I can now send 2 from B to A, because I edited the capacity on that edge. And then I can send 4 from A to T. So this one actually has a minimum capacity of 2, and that's called backflow. There wasn't a capacity of 2 to start with, it just appeared because I chose to do this path first. Okay, so I'm going to send 2 down here, which means I'm going to take 2 off this one, which means I can still send 3 down there, and which means that I've sent this to back this way. So now that edge is saturated, has a full capacity again, and I've sent. Sorry. Yeah, that's right. And then I sent 2 down here, and so I've still got a capacity of 2 there. Okay. Okay, and now you can see that I can do the routes S to A to T, which is probably the one you would have started with if you were given the choice. And the capacity on this one now is just 2. So I'll get rid of that. And now that edge is saturated. And I'll take 2 off this one. And you can see that now this edge is saturated. This edge is saturated. This edge is saturated. So I can't actually get any more through this network. So I sent 2 down there, and that gives me a max flow of 6. Okay, and now I'm just going to look for the cut, the minimum cut, and you should be able to see that the minimum cut is there, 4 and 2, and they match. Okay, so that's the idea of backflow. If I've sent something down a pipe, then I have a capacity to push the flow back through the pipe, and that's why we keep track of all these arrows on the network.